This is a video on how to get the equations of the tangents to an ellipse. We've got this ellipse here, which we started off with the equation of it, and that's this one here, which tells us that the center is in 2, -3. So that's the center here. X is 2, y is -3. And has got a horizontal axis of 2 to the right, 2 to the left of center, and 5 up, 5 down from the center. That comes from here. 4 is 2 squared, 25 is 5 squared, which gives us the A's and B's of the ellipse. Now, for us to be able to work this on our graphics calculator, we, instead of going into the conics mode, we need to go into the graphics mode. But before we do that, we have to rearrange the equation as an equation of y as a function of x. And as you can see, we've got two values for y. So one is the top one, and this one here, the green dots, and the other one is the purple dots. Yes, one is positive, one is negative. So the next thing I need to do is go into graphs and enter the top equation, which is going to be 5 square root so 5 square root, and because I want to take square root of a whole expression, I need to write some parentheses. So 1 minus x minus 2 to the power of 2, and that's divided by 4, close the parentheses, and minus 3. All right, and now I can draw that and do Shift G solve, and I want to find the value of y when x is 1. That's my first concern. So I want to find, because I'm being asked to find the tangent in x equals 1, I also want to find the y coordinate of that point. So x equals 1, and I've got that point, which is 1.33, and so on, which is that point there. So I've got this point, 1.133. The next thing I want to do is work out the other point of intersection, this one over here. So let's do that. I exit this and go back up, and I need to enter a minus, execute, and draw that, and I can see the bottom part of the bottom half of the ellipse. So now if I do Shift G solve, and I want to find the y for x equals 1, that is -7.33, -7, so 1 and -7.33, which is that point there. Yes. 1.733, yes. Anyway, that's the point of intersection. So now I also need to find out what the gradient of each of these lines is. So I'll go back into my graphics calculator, exit that, and I'll do the top part first. So I'll get rid of the minus. Execute, and now I enter the gradient function, the derivative of what I have at the top. So I press options here first, and now calculate F2 d by dx of that expression at the top, which is 5 square root of 1 minus x minus 2 to the power of 2 divided by 4, close the brackets, minus 3, and execute. And now let's draw the two graphs. Now if I go up a bit, as you can see, the gradient as I go along the ellipse, the gradient is decreasing until it's 0 at the top of the ellipse, and then it continues its decreasing trend. So this looks all right. Now I can try and calculate the value of not the function, but of the gradient function when x equals 1. So y2 is d by dx of the function, and x equals 1. So the gradient when x equals 1, the gradient is 1.4437 or 1.4434. I used 1.4433, and we need to do the same thing for the bottom part. So I exit that and change the signs. This one is going to be minus, execute. The other one is going to be minus as well. So we're doing minus 5. And execute, and now draw. And we've got the gradient, which is 0 at the bottom turning point. So the bottom turning point of the ellipse has a gradient 0, which is shown by the graph of the gradient function. Now I can use the same gsolve and calculate the y, not of f1, but of the gradient function. Execute that, x equals 1, and the gradient is negative 1.4433, and so on. So that's this one here. Now, by knowing these points, this and this, I can write the following equation. 1.4433, that's the 4433. So 1.4433 equals to y minus y1, 1.33, 1.33 over, right, I need to add some brackets here, and that's over x minus 1. And here we are. That's my first tangent. The second tangent is going to be negative 1.4433 is equal to y, and y2 is, the other y is negative 7.33, so minus negative 7.33 is plus 7.33 divided by x minus 1. And there we are, the second tangent. That's pretty much it, and that's how you can work out your gradients and your points of intersection and everything you need for writing down the equation of the tangent. So we first write the equation. Need to keep in mind that it's plus or minus, this being y equals, it's a y squared, and then we take the derivative dy by dx of the same function to find the gradient. From this one, from the top one, I get the points of intersection of the coordinates of the point I'm supposed to work out. So g solve and y calculate, and I do that when x is 1, and I get the value of y when x is 1, and I do the same for the top part. And then from the derivative part of y2 is the derivative of the same expression, I get the gradient in that point. So calculate the y of y2, and x is 1, execute, negative 1.4433. So that's the gradient of this line here. That's the gradient of the bottom, the descending tangent. 1.4433 is the gradient of the ascending tangent. And that's pretty much it. Thank you very much for watching.